So our next problem is count set bits in a number. Okay, count set bits in a number. So let's say we have a number 9. Okay, let's say we have a number 9. 9 can be written as 1001. Okay, now I want to count the number of set bits. So 1, 2, we have 2 set bits. So we need to return the answer as 2. Okay, let's say one more example. Let's say we have 15. So 15 can be written as 1, 1, 1, 1. Okay, so we have how many set bits? 1, 2, 3, 4. We have 4 set bits. Okay, so how we can solve this? First, what we can do? We can iterate through each bit. Okay, we can iterate through each bit and check if this bit is 1. If it is 1, we'll increment the counter. Okay, we'll take a counter variable and we will increment the count. Okay, so first check this bit, it is 1, increment the counter, counter will be 1. Then again check this bit, if it is 1, increment the counter. Then again check this, if it is 1, increment the counter. Then again check this, it is 1, increment the counter. Okay, till we have the number. Okay, till we have the number. So what I can do, I can just iterate through this. How I can iterate through this? I will take a mask. Okay, I will take a mask initially as 1. Okay, and we'll do a AND operation. So if I do an AND operation with this, it will be 1 only. Okay, so if it is 1, increment your counter will be initially 0, now it will be 1. Okay, and after this, either see, either left shift the mask or right shift the number. Okay, better to left shift the mask because I don't want to do changes in number. Okay, so again this is my first step. In second step, again take the same number. Okay, after doing left shift, one left shift. Okay, one time, so it will be 1 0. Again do and it will be 0 1 0 0. This is again non-zero, so increment the counter, counter will be 2. Okay, again do the left shift, by 1, so it will be double 1 double 1, and your mask now will be 0 1 double 0. Okay, again it will be 0 0 1 0, so it is again non-zero, so increment your counter. Okay, now in next step, again take this number, do an operation with. So take the left shift. If you do left shift, it will be 1 triple 0. Okay, so it will be 0 0 0 1. So it is again non-zero, increment the counter. Okay, so we will keep on doing this. Okay, we'll keep on doing this until my mask is less than equal to my number. Okay, so now if you do left shift, it will be 140. Okay, it is greater than your number, so I will stop it here. Okay, you can put various conditions. Okay, if you do right shift, you can put whether your number is 1. Okay, so every time you will check if your number is greater than 1, equals to 1. So you can put a lot of conditions. Okay, so that can be one condition. Okay, now what will the time complexity? So let's take 15. Okay, it is 1 1 1 1. So in verse time, what can happen? I can iterate through this total of 1 2 3 4 4 times. Okay, and if I roughly say this, it is nothing but order of log n times. N is our 15, right? So it can be run till order of log n times in worst case. Okay, and space complexity is order of 1 only. Okay, but this log n time can be optimized. So we have one algorithm which we have, I guess, already discussed. If not, it is Bragg Kernighan's algorithm. Kernighan's algorithm. Okay, what does this algorithm says? This algorithm says that if I take n and do AND with n minus 1, it will clear my rightmost set bit. Okay, so if I take n and do AND with n minus 1, it will clear my rightmost set bit. Okay, and that we will use for this problem. How? Let's see. So let's say we have 7. Okay, 7 can be written as 0, triple 1. Now I want to find the count the number of set bits in this. Okay, so if I do n and n minus 1, it can be 0, triple 1, and it will be 0, double 1, 0. If I do AND of this will be 0, this will be 1, this will be 1, this will be 0. Okay, it is nothing but 6. So again if I do 6 and with 5, it will be 0, double 1, 0. It will be 0 and 1, 0, 1. Okay, so this will be 0, 0, 1, 0. Okay, it reset my second set bit. Now what is the value of this? It is 4. Okay, I will keep on doing this until I will get the number. So it is 4. Do AND with 3, it will be nothing but 4 can be written as 0, 0, 1, double 0. Okay, 3 can be written as 0, 0, double 1. So it will be 0, 0, 0, 0. Okay, so we have done operation 1 time, 2 time, 3 time. Okay, so at worst, this will also run for order of log n times. Okay, see in this operation, but we have done 3 times. Okay, we have done 3 times. It is almost order of log n. But so what if we have 1? So it will be 0, 0, 0, 1. Okay, so what? It will take only one pass. Okay, so if I take 15, okay, it can be 1, 1, 1, 1. So I'll follow the Bragg algorithm 4 times. Okay, so 1 time, 2 time, 3 time, 4 time. Every time it will reset my rightmost set bit. So if we have 4 set bits, it will run for 4 times. Okay, so at worst case, this algorithm also takes order of log n times. Okay, order of log n times. But for best case, it can be optimized. Okay, it is optimized. So if you take 4, 4 is nothing but 0, 1, double 0. Okay, so in one traverse only, we will get our answer. How? So I will do AND with 3. Okay, it will be 0, 0, 1, 1. We'll get 0 in one traverse only. But if we follow the previous approach, we have to go like this 3 times. Okay, so for best case, this approach is optimized, and in worst case, it will also take order of log n times. So this is about our next problem, which is count set bits in a number. Okay, now let's move forward to next problem.